welcome to the lesson on logarithms. The question is, what is a logarithm? We're going to find out that a logarithm is the exponent to which a base is raised to get a specified number. So 2 to what power gives us 8? We know that 2 to the third power will give us 8. So this is just a little insight to what we will be doing with logarithms. But before then, what we're going to do is on the notes. First thing we're going to talk about is the properties of exponents. There are a few properties we're going to go over. First thing we need you to know and definitely remember is that all logs must be positive. All logs must be positive. No negative logs. Just like in Miss Meyer's class, you cannot have a negative attitude. So, no negative attitudes, no negative logs. First property we're going to go over is the one called the product rule. Product is multiplied. So as you can see here, m is being multiplied by n. This right here is a base, and it actually should be written like this. Log base b of m times n. Not sure why it came out like that on the PowerPoint, but this actually should be a little lower. Okay, so this reads log base b of m times n is equal to log base b of m plus log base b of n. So here are some examples right here. Log base b of x times y is the same as log base b of x plus log base b of y. So what do we notice? We notice that x and y were being multiplied. So what are we going to do? Keep it with the base, but we're going to add it. The next one, you do not see a base right here. If you don't see a base, it is actually 10. We never write when it's log base of 10. So 6 is the same as 2 times 3. So log base 10 of 6 can be written as log base 10 of 2 plus log base 10 of 3. Here's one. Log base 10 of 39 times b is the same as log base 10 of 39 plus log base 10 of 3b. What we have next? Next thing we have is the quotient rule. This is where we're dividing, and what we're going to do is we're going to split up the numerator and the denominator. So this is log base b of m minus log base b of n. Because it is division and logarithms, you'll find out will undo, or the inverse of exponents, the rules of exponents, just like the rules of logarithms. When you're dividing, you subtract. So this log base 5 of x over y is log base 5 of x minus log base 5 of y. I want to skip down to this last one. We have a product, m times n, and we definitely have division. So we have a few things going on here. We're first going to show the log base 2 of m plus log base 2 of n. That'll represent the product. And of course we have our subtraction here, log base 2 of p. So we took a condensed problem and we expanded it. Next is the power rule. We know what a power is. Power is an exponent. If you look at the left-hand side and the right-hand side, what's the difference between the two? Well, actually, the power, which is over here, is actually being multiplied times the log. And yes, that is a rule. So here we'll notice that log base 5 of b squared is the same as 2 times log base 5 of b. So when we have the word log, no one can be in power. All exponents have to come down. This one, we got a lot going on. We got a product, so we're going to split a to the third power up and b to the fourth power. Then we're going to take the exponent out. So this 3 was here and this 4 was here. But since we wrote the word log, we don't need an exponent. Let's go to the next slide. All right, we're going to work work backwards here. Now we have an expanded problem, and we're going to condense it. So we know we have a subtraction here, so definitely some division. So we'll start off writing log base 4 of 4 divided by log base 4 of 16. We write it as 1 log in the end, log base 4 of 4 over 16, which reduces to log base 4 of 1/4. I will let you work on this one. We'll do this one right here. We'll write it, we have subtraction, so we're going to write it as a condensed logarithm. And so this is going to be log base 2 of m squared over log base 2 of n to the 4th. I'm going to write it as 1, and this is going to be log base 2 of m squared over n to the 4th. Let's see what you got for the next one. Here we go. Display of the answers. Moving right along. This is expanded, and let's condense it. We have a lot going on here. Well, we know we have a plus. Let's put all our pluses together. We got log base 10 of 5 plus log base 10 of x plus 4 log base 10 of 5. Well, all of these are what? Adding. So when we definitely add, what do? We're going to multiply. So that's going to be log base 10 of, and what are we putting together? 5 times x times, let's go ahead and move this back into power, 5 to the 4th power. Now all of these positives are going to make up our numerator. Well, when I condense this, I have log base 10. Remember, if nothing is written here, it is a base 10. And then in parentheses, I have 5 to the 1st power times 5 to the 4th power, which is what? 5 to the 5th power, x. And of course, we have our 1 subtraction. So we're going to do log base 10 of 3. Of course, if we write it as 1, we just write log 1 time, and 5 to the 5th power times x over 3. Whoa, look at this. This is long, it's complicated, a lot going on, order of operations. We have these parentheses here, we got a power right here. Try this and see what you get. Pause the video, see what you get. Voila. Here is our final answer. You definitely are welcome to pause the video and go through the steps and compare it to what you have. Alright, let's try something more complicated. I'm going to get you started on this one, and I would like for you to try this one on your own. I'm going to go ahead and rewrite this one for you just to get started. Log base x, and I see division, and so this is going to be rewritten as 2 times x to the 1/2 power, all raised to the 3rd power, over log base 8 of 5 to the 3rd power. Okay? All right, let's see what you can do with that. Press pause. I'll show the answer, and that will conclude. Let me know if this is what you got. If you have any questions, bring it to me or bring it to my attention, and I will help you sort through it, and we'll do some practice problems.